But no, my biggest question about all this. So everything you just showed me is pretty damn cool. I'm not gonna lie, it really is. Especially the trust to be able to create this networks with so little overhead. Well, I use that word overheads very specifically there. Can we talk about like, I mean, talking across the internet takes a while, right? Like in general, there's a lot of unknowns here. So how does that work? Like if I have my database over somewhere else,
Yeah,
obviously I'm not going to want to like. Can you talk about the overhead and the latency and
yeah, I can
what
definitely
having this level? Yeah, go ahead.
Yeah, I can definitely tell you how I think about it. Like, I can imagine that there will be some real-time applications that have very narrow and rigid requirements for which they must be optimized for overhead. And it would just be a case-by-case basis whether adding an overlay to that picture is a deal breaker. I tend to suspect that it's not going to be in most cases. That it's hard to imagine applications that wouldn't be able to tolerate the amount of additional latency that would be introduced. And it just adds another degree of complexity, but it's certainly doable with the existing tooling to optimize that fabric for delivering a specific application in a specific way. And
So
so that's
yeah,
something we
and
can talk about a little bit deeper later, but there's configuration that you can do to kind of steer the traffic in the way that's optimal.
yeah, and on top of that, I mean, a very non-trivial amount of work has already gone into picking the best path, if you will. And we have done internal tests that show throughput. So latency is not the same thing as throughput, right? So we've done lots of tests that show our network doing better than the open internet, almost always beating
Right.
open internet. In some places destroying the open internet. But there are some times where the open internet and just TCP is, 5% slower, right? Like
Yeah.
that's just noise. And we have a fellow, Michael Quigley, who does all that work, a really talented engineer, and he refers to it.
Yeah.
I love the term as the internet weather. Right. So
Exactly.
depending on where you are, the internet's weather can be good, it could be bad. And in fact, JJ and us were just talking about his internet weather. He has
Yep.
a friend who streams with him who's relatively close and says that he's got perfect streaming, but JJ once in a while has some troubles. So it's
Well,
a great example of how that could work out. But that
So
fabric that Ken had talked about, sorry Ken, I'm trying to just slip this in. That fabric that Ken had talked about actually already is doing round trip calculations. It has baked into it, what is the fastest route from here to there. So if you take one of our, we call them routers, if you take one of our routers and you plop it down right next to your service, and then you put some, say, tangential routers around the world or around the state or whatever, however you want to think about it, the geography,
mhm.
that fabric is constantly monitoring everything. And what is really mind blowing to me is, you go into command line, Ziti list links, right, and that'll show you all your links. It'll tell you your current latencies. It's so amazing to me how many times it's faster to take 2 hops to someplace than it is going straight there. So like a lot of times you'll onboard onto this router, it'll bounce to that router and bounce over to here, as opposed to just going straight from here to there. But that's the calculations at work, and that is just adding up the total path time. It's very naive right now because that's what we have is the total path time, but it finds the quickest one, sends your traffic down that route.
smart routing. That's the adaptive piece of the permissionless mesh. So you basically have like on ramps and off ramps with the edge piece. So you can configure how you get on and to and off of the ZD superhighway, but that mesh
Nice.
topology is adaptive. So it'll go around internet weather, and you can always add points of presence for that overlay according to your needs, like cost benefit, right?
Rock on. That's really, really cool. Okay, so we've talked a lot, and one of my rules about streaming is we need to on keyboards as quickly as possible because we got to show off your awesomeness here. So who wants to? So I'm not saying tongue in cheek. I'm actually serious here. It sounds like we need to have a follow up here in a little at a time, where we do the self hosted one that Clint you linked earlier, and there was something else that we were like, hey, that would be great for a follow up. What was that? What was
That
that,
was the
Ken?
throughput and overlay,
That's right.
the yeah, the
Yeah,
overhead.
The overhead.
Like,
Yeah.
or just exploring the broader question of like, how do you decide whether to optimize for, like, whether to maximize the minimize the overhead, or maximize the programmability? Because there's questions there are questions here. We spent a lot of time thinking about this, right? And
Mhm.
there's a reason why we went this way, and we think that there are some very appealing trade-offs, and they're usually not as much of a trade-off as you might fear, because
Yeah.
we just sort of learned the hard way, trial and tribulation, right? And coming up in systems and networks, that you have to take these things into account, because those microseconds add up. But these days, with resources being what they are, and costs being what they are, it might make sense in a lot more cases. We think it does. Feel powerfully certainly that it does make sense in a lot more cases to optimize for that programmability.
Mhm. Nice. Rock on, man.
And we can see Mattermost too.
There you go. There you go. All right. Well, gentlemen, how about you say goodbye to our audience?
Later, Al.
JJ, yeah, thanks for having us. It's been great.
Thanks everyone for joining, and bye.
Bye.